All right, in this video, I'm going to review a couple things. I'm going to review sig figs, and I'm going to review doing some unit conversions. So I already mentioned in the earlier video about making sure that your measurements follow sig figs based on the precision of the lab equipment that you're using. But in this class, you're also going to have to pay attention to sig figs when you're doing calculations. So the first thing I'm going to review is how you count them. And the way that I usually teach it, for those of you who have forgotten or maybe were taught a different way, I usually in Chem 1 have students picture the United States and the Pacific Ocean's over here and the Atlantic Ocean's over here. In terms of numbers, I say that the Pacific Ocean stands for the decimal point being present, and the A stands for the decimal point being absent. And so you start on the side of the number or the side of the country based on the number that you have. So if I start with 80.40, the decimal point's present, so I'm going to start from the left side of the number, just like the left side of the country has the Pacific Ocean, and I stop at the first non-zero number. So in this case, I would stop at the 8, so everything after that point is significant, meaning this number has 4 sig figs. If I had a number like, let's see, 0.00840, so the number at the decimal point is present, so start on the left side, and I'm going to stop at the first non-zero number, so that would be this point, and then everything after that is significant. So this number has 3 sig figs. Now if you look at whether the decimal point is absent, so if I have a number like 8040, the decimal point is absent, so now I'm going to start on the right side of the number like you would on the right side of the country with the Atlantic Ocean, and I'm going to stop at the first non-zero number, and so this number has 3 sig figs. The reason why that 0 here is not significant is because we don't know if it's exactly 8040, maybe it was 8039 that was rounded, or something like that. So that last 0 is not significant. It's like the extra number on your graduate cylinder. It was an estimated amount, so it's not significant. If you had a number like, 1000, well, start from the right side of the country where the Atlantic Ocean is, or the absent decimal point, and stop at the first non-zero number. So this one only has 1 sig fig. But if I were to put that decimal point there, now that's an unusual way to write a number, but that would make those 3 zeros significant, and so now it would have 4 significant figures. We do use scientific notation quite a lot, as you know, in chemistry, and so if you're looking at scientific notation, it's the same idea, you just ignore the times 10. So if we, let's just say, look at 6.02 times, let's just use Avogadro's number. Now that's an exact number, but let's say that it's not. You just kind of ignore the times 10 part, and you just look at this, and so this one has 3 significant figures. If you have 1.0 times 10 to the negative 32, ignore the times 10 to the negative 32. Just look at the 1.0. That has 2 sig figs. Now back to exact numbers. Exact numbers are just that. They're counting numbers, so if you say that there are 6 people in the classroom, or Avogadro's number is an exact number, when we're looking at exact numbers, they never limit the number of sig figs. Which is why if you're doing mole conversions and you're converting from grams to moles, the fact that there are 12.01 grams of carbon in 1 mole, well, that's an exact number. Both of those are exact numbers. So we say that it's not going to limit your sig figs. But if you had 6 grams, that's in a measured amount, so then your 6 would be limiting your sig figs. But exact numbers never limit sig figs. So unit conversion numbers, formula weights are considered exact numbers in chemistry. Avogadro's number, those are all exact, and we just sort of ignore them when it comes to sig figs. Now, when you're doing calculations, hopefully you're familiar with the multiplication and division rule. I know that that's one that we focus on a lot in Chem 1. So when you are multiplying or dividing, the number must have the same number of sig figs as the least precise measurement, or another way of saying that is the measurement with the fewest number of sig figs. So for example, if I am looking at multiplying 4.2 times 6.74, if you type this number in your calculator, the calculator says 28.308. Well, that number has way more sig figs than you need, so look at the numbers you're working with. 4.2 has 2, 6.74 has 3. So you're going to go with the least precise, which would be the 2, which means your final answer needs to have 2 sig figs. So I would round this one to 28, and that would be the final number. When you are doing addition and subtraction, you are looking at the least precise, but instead of looking at the whole number, you're just looking at the number of decimal places. So for example, if I'm using the same numbers I did before, but now let's add them. If you were to type this into your calculator, it would say 10.94. Well, we look after the decimal point. So this one has one number after the decimal point, and this one has 2. 1 is least precise, so then my number has to only have one number after the decimal point. So then the result would be 10.9 is how I would record it. Keep in mind when you're doing calculations that result in multiple steps, the sig figs are going to be limited by each step in your order of operations. So just keep that in mind, that you're going to have to maybe do some multiplication and some addition in your calculations, and the sig figs are going to be limited when you follow the order of operations. So just keep that in mind. And whenever you're doing calculations, make sure that you round at the very end. So keep a whole bunch of extra numbers until you're ready at the very end, and then you can round. Right, and we're going to do a couple calculations just to remind us how to remind you how to do calculations. I'm going to give you the answers, but I would recommend pausing this video for a second and calculating them all just to make sure you follow sig figs. So for this first one, if I'm following sig figs, you're going to get that number because of the 3. Ooh. The second one, they both have 2 sig figs, so your answer should also have 2. This one has 3 sig figs, this one has 2, so your answer should have 2. For this one, we're now adding, so you're going to go 2 numbers after the decimal point, so your final answer should be 15.00. And now this one is an order of operations situation, so we're going to do the subtraction in first because it's with the inside the parentheses, so you get 0.50 with sig figs, and then divide it by 0.4, the one on the left, and you end up getting 1.25. Well, 0.50 has 2 sig figs, this one has 3, so my answer needs to have 2, so I would round this to 1.3. Alright, and the last thing in this video I'm going to go over is unit conversions. So remember, we have the English and the SI unit. We, of course, will probably be using the SI unit more than anything in here. I would on the the right side here is this chart. I would recommend that you memorize what's in between these big black lines from mega to nano. Those are the ones that we'll be using most often. It's the ones that most AP graders are going to require that you know. So if you don't already know them, I would make sure to review them. I'm assuming that many of you know from kilo to milli. You just need to add a few more on either side. Of course, if you are familiar with the acronym, King Henry died by drinking chocolate milk, and then you can add a few more. So there's for micro, and there's nano, and then if we add 2 more on this side, we get mega on that side. No. Okay. So just a few reminders, just a few practice. So King Henry died by drinking chocolate milk. And so we're going from hectoliters to deciliters. So if you want to move the decimal point, you would do it 1, 2, 3 places to the right. So you end up getting 250 deciliters. So 1, 2, and then 3. And again, you can also look and see that there are 10, 100, 1,000 deciliters in a hectoliter, so you could take 0.25 and multiply it by 1,000, and you get 250, whichever method works best for you. So if you are looking at the next one, converting 780 nanometers into micrometers, so let's just add the 2 more that we need, and so we're going from nano here to micro, so it's 1, 2, 3 places to the left, or divide by 1,000. So 1, 2, 3, you get 0.78 micrometers. Or if you wanted to look at it the other way, you would get that and divide it by 1,000, and either way you get 0.78. So whichever way you prefer. And looking at dimensional analysis, this works for non-SI unit conversions where you can't just move the decimal point or multiply by multiples of 10. And so if I'm converting 10 miles per hour into furlongs per fortnight, you need... Okay, so in order to do this conversion, you will need to know that there are 20 feet in a furlong, and you will also need to know that there are 336 hours in one fortnight. Now, these are obviously not conversions you ever need to know, but there they are. So in order, I'm going to try to get the meters to cancel, excuse me, the miles to cancel. So I know that in 1 mile there are 5,280 feet. And now my miles cancel, and then I'm going to get the feet to cancel. So I know that there are 20 feet in 1 furlong. So those cancel. And now I'm left with furlongs, and I can now get rid of the hours. And so there are 336 hours in 1 fortnight. And so my hours cancel. And then with dimensional analysis, you just multiply across the top. So 10 times 5,280 times 1 times 336 divided by everything at the bottom. So divided by 20, and you end up getting 8.87 times 10 to the 5th furlong per fortnight. So it's important to remember when you're doing this dimensional analysis that whatever unit's on the top needs to go on the bottom of the next section. And following sig figs, 10.0 has 3, so my final answer also has 3. And the last thing in here that we're going to look at is making sure that you're keeping track of cubic volumes. It's a little bit trickier. And so if you know that 1 liter is 1 cubic decimeter, if I'm trying to figure out how many cubic centimeters are in a liter, well, 1 liter is equal to 1 cubic decimeter. And I know based on my conversions up here at the top that there are 10 centimeters in a decimeter. Well, this is going to equal 10 centimeters, but I'm cubing it. So just you have to remember that if you cube the unit, so I'm cubing the centimeters, I also have to cube the number. So that would be 1,000 cubic centimeters. So just remember when you're looking at cubic volumes, you have to cube the number in addition to the unit, not just the unit. And very quickly, I'm going to review some temperature units. Hopefully you remember the unit conversion between Celsius and Kelvin. So you add 273.15 to Celsius to get Kelvin. Now I'm not super concerned about the 0.125. If you just remember 273, that's fine. This here is the conversion between Fahrenheit and Celsius. Not one that I'm ever going to ask you, nor does the AP exam require that you know that conversion. But if you were curious, there it is. But you do need to know the Celsius to Kelvin conversion. And that's it for the unit conversion video.